All right, good morning, everybody. So welcome back. And wow, this is the full class. Cool. Yes, so it begins indeed. All right, yeah, so the A section, there were like 15 people in there. And B, we've got 26 in here, so this is good. All right, let's see. All right, well, welcome to CSE222. So yeah, this is the latest class available. I know I've been like on such a cool sleep schedule, like going to bed at 4 in the morning. So this was a little brutal this morning, but that's good stuff. All right, today we are mostly going to be going through sort of introduction to the course kind of stuff. We probably won't get into actually talking about data structures until tomorrow. But we have a number of things to go over today, and Canvas is up, and if you look at Canvas, you'll see there's a few things you need to do in the next day or two. There's an ODP posted, which is due tomorrow. There's a online quiz, which is due tomorrow, and there's a homework one, which is due on Wednesday. So what I want to do today is, for some of you, review what we've done in 224, and we're going to have to do this quarter. Or if you're new to the sequence and you haven't done this before, we'll go ahead and go through the steps for that today, and I'll tell you where to find more help. So ODPs are opening at 10 in the morning now, and they close at 10 the following morning. So if you tried to assess at 1 a.m., it wouldn't work. But ODP 201 should be open now. All right, so let's talk about intro stuff. So let me run quickly through the syllabus. 10 o'clock in the morning. So they open at 10 a.m. They close at 10 a.m. the following morning. So not p.m. All right. So let me pop through the syllabus really quickly. All right, so data structures in C. So this is an intense programming course. It's all done in C, and it's going to involve basically manipulating the memory of a computer at a very low level, coming up with interesting ways to store and organize information in the memory of a computer, and then writing the code ourselves to do that. Now in spring we'll do advanced data structures in Java. We'll use a lot of machinery that's in place for us to do this manipulation of memory. But in 222, this course, we're going to build all the stuff ourselves from the ground up. This is like doing derivatives with epsilon delta notation, right, as opposed to just using the formulas for finding derivatives. It really helps you understand how these data structures work, and you have to understand how they work and be able to use them efficiently. So it's going to be intense C programming, intense debugging, longer assignments, but also really cool stuff. So text is open source. It's online here. A lot of the stuff is very old, so you don't need a 2021 textbook on data structures, right? But there's tons of resources out there. But this is a good, freely available textbook on data structures. Having a C programming text will be useful too. these are the course outcomes, the particular things that you're expected to come away from this course understanding. But this is the more sort of detailed discussion of topics we're going to go over. And we'll probably cover all of these things. We'll probably cover more than what's in here also. But I would like to get through all of these things in a fair amount of detail, and then add extra stuff as available. May not get into graphs much. All right, so course policy, support services, DSS accommodation. You can read through this on your own. We've gone through this in 224. It should be stuff you've seen before, but let me know if you have any questions. Code of student conduct, same as usual. Class cancellation. It did not snow today. It always seems to snow the first day of winter quarter. So we probably won't have class cancellations because I can usually get to my desk even if it's snowing outside. NECS course policies for other information as usual. But the more relevant part of all of this is this additional information which is posted on Canvas right after the syllabus. So let's talk about that one in a little more detail. So additional course policies. So assessment, what's your grade based on? So number of components, programming assignments. There's going to be 5 large programming assignments a week long each, and then maybe a few smaller assignments along the way. 20% of your grade. ODPs are back, 15% of your grade. Online quizzes on Canvas, 10%. Midterm is 20, final is 25, and the service learning project is also back, and that'll be 10% of your grade. And we're going to talk about the details of these in the next 30 minutes or so. Keys to success, you can read these. A lot of these are repeats of things that I've said again and again in 224, but a few highlights. Number 1, come to class and participate. Okay, don't just count on watching the recorded videos. That may be more convenient, but it's not going to give you the same benefit of actually watching the lecture live and participating, asking questions, right? Thinking about things as we talk about them and trying to figure out what they mean. You want to follow this stuff actively. You want to participate. That's going to make it more meaningful to your brain when it's trying to code this information internally. Bugs are your friend, okay? If you write code and it's not working correctly, don't just start changing things and hope that you come across a lucky combination that works. When something's not working, try to understand what it's doing, okay? That is your golden opportunity for learning. That is the moment where there is a clear example of something that you thought was one way, but it's really a different way. That's what you want to figure out, right? Getting something that works, yeah, that's great. You get the points for it. You can go on to physics or whatever else. But the real goal is to get better at programming, to get a clearer understanding in your mind of these concepts, to get a clear sense of what is a linked list, how do I create a new node, how does that node work its way into this data structure, how do I traverse a tree, how does recursion work, right? And these things we learn by hitting the walls, the bugs, the problems, and digging down into those, right? So when you find that your code's not working, that's what you want to spend your time on now, is debugging, right? Understanding what your code's doing, figuring out what the behavior is and why that's different from what you expected, okay? So we're gonna hit this again and again, and when you run into a problem, don't just throw it away. Don't rip the wires out of the breadboard and start again, right? Get better at debugging, okay? Bugs are kind of inevitable. Your real goal is what can you do when you encounter a bug. And if you're good at debugging, right, that's one of your pillars to being, you know, an amazing programmer. Programming assignments and homeworks are all kind of lumped together. So they're all in the same general category of 20%. You have a homework 1, which is a 20-point hello world, basically. I don't know if I'll have other homeworks, but they might be like short programming assignments or things related to programming assignments. So that's how PAs and homeworks differ. ODPs are one-day things. We'll talk about ODPs in detail in a minute. Usual stuff, right? Start early, leave yourself time to struggle, because that's where the benefit of doing these assignments comes in. Stick to Unix, stick to the command line, stick to VI. Okay. Getting help. So there's 3 ways to get help from me in this course, and if you're looking for help, you should come to me for help. Okay? There's lots of information available online. There's Stack Overflow, there's Chegg. None of those things are going to help you. Okay? They're going to take you down other paths of twisty-turny passages that all look alike, right? So come to me for help, okay, if you need help. You got 3 options for doing this. The first and best option is during class time. Okay? I always ask, any questions? How's the homework assignment going? How's PA3? Any questions on this, right? We'll go through the ODPs in class. Think about these things as we're talking about them. Don't just write down notes and hope that they make sense later. Think about them during class time. Okay? So that's your first place for help, right? And then if something's not making sense, just open up your microphone and say, can I ask a question about what you just said, or I have a question on this, or I don't understand this, right? Feel free to use your microphone, okay? Pretend we're in an actual classroom and I can't see you raise your hand, but just go ahead and start talking. All right, so that's your first option is during class time. Second option is office hours. Office hours are an hour a day, 8:45 to 9:45. You're competing with 4 classes and students who want advising. Okay, so that's not a guaranteed time to get a lot of help. So, and that's right before class starts, and it's right before the ODPs are due. So, yeah, question about ODPs, go for it.
Okay, so can you hear me all right?
Yep, absolutely.
Okay. So the ODP says that we have to write a sum which accepts 2 integer arguments. Does it have to accept only 2? Because that's more complex than not.
It's easier to accept an exact number of arguments.
Oh, okay.
Yeah. And we're going to actually go through ODP 201. I'll actually work through the whole process from start to end in a few minutes.
Sorry, I didn't.
Oh, that's okay. That should help clarify it too. All right, cool. Unsolicited example of a good way to ask questions in class. So thank you. Ask questions during class. That's your first option. Come to office hours. That's your second option. Third option, email. Okay. I'm only going to respond to emails once a day, and that'll usually be in the morning, right around office hours. So if you write me in the middle of the day, don't expect a response until the following morning or afternoon. Now, a few exceptions for this, right? If you have something urgent, right? Like something urgent like I can't get logged into the Linux machine. Right, and this is the first time you're trying to log in because you're new to the sequence, right? I'm not going to make you wait until the next day to get a response. But if it's something like, my program doesn't work, what's wrong with it? I may not even respond to that, okay? That's really an office hours kind of question. Or if it's a more general question, I don't know what we're supposed to do when you say, check if the stack is empty, right? That's a class time question, okay? So we're going to be really careful about how we ask for help. All right. So that's getting help. Discord server, that's another resource. So Discord server, same one as in fall. There's a 222 channel. A lot of people have hopped on it already. I don't normally hop on that on a regular basis, but you can usually find other people there for like general questions. Don't ask somebody to fix your code for you, but did the teacher say anything about, what we do if the input string is empty, right? That's a good question to ask on Discord. Someone can probably help you with that. All right. I forgot my countdown timer. All right, Linux access. So we're on the Linux server. I recommend using Linux in your own environment. If you have a machine that boots to Linux, that's great. If you only have a Windows machine, I strongly recommend using VirtualBox. There's some videos posted on the YouTube channel, and go ahead and follow that if you want to set up a Linux environment. You can also use the Linux server, okay, and we're going to work through that in a minute. We make use of Git here. I recommend using Git for your own backups, and all your homework submissions are done through Git. So if you're new to Git, definitely come and let me know. Yes, a question, go ahead.
Yeah, I had posted this on the Discord channel. I'm not sure if it was the right one, because I didn't see the Discord posted under the modules. I found it in the other course, discrete structures. The question was about the Ubuntu for Windows application. Wondering if that is an acceptable simulated Linux environment versus using the VirtualBox.
So you're welcome to try it. I myself have not had luck with that, and they seem to keep improving it, but more often than not, when I've had students try to use that, it works well, except, you know, this thing doesn't work, and to make this other thing work, you have to do these 5 steps, and this one thing doesn't work anymore. So some people really like it. I think the cleanest option is to have a full-blown Linux environment that already supports GUIs and X windows and things like that. But you're welcome to try it, and certainly for compiling code and SSHing into a server, that should work perfectly fine. I believe that to get that running, that hobbles your ability to use Dropbox effectively, though, or not Dropbox, VirtualBox. So it becomes a kind of one or the other. But yeah, it's totally up to you. Experiment. Play around with them, see what works for you, because a lot of it is personal taste too. So whatever you like. So yeah, the Linux environment is the same as 224. You don't have to do anything in addition to what you did back then. You can use SSH. You can use whatever you want to connect to the server. You can use PuTTY if you like. Whatever gets you there, that's fine. And yeah, for Windows 10, you already have SSH available, so you can use that. If you're on OS X, you have SSH available from a terminal shell. If you're on your phone, you can, get a SSH client and connect to the Linux server like that. So that's all set. All right, and I don't know what VS-Dode or VS Code is to connect to the server, but anything that connects you to the server through an SSL connection should work fine. All right, so say again.
Another question. With the like say that we have previous projects.
Your audio is breaking up a bit. Try again.
Here.
Getting a few syllables.
Yeah, I'll type it out.
Okay. Yeah, go ahead and put it in chat. Let's see, instructions for ODP 201. So we'll run through ODP 201 in a minute, and I'll show you the instructions there until you get Canvas access. All right, so attendance. I'll be recording attendance as usual, but I'm not going to be doing anything in particular with it for now. If I change that policy, I'll let you know, but I will be noting attendance. Academic honesty, late work, go ahead and read those on your own. Same drill as 224. Do your own work. Don't look at code when you're trying to write code, because once you see code, you can't unsee it. And even if you continue writing your own code, it's going to be derivative of what you've seen, and that can get you into problems. And it can deprive you of the opportunity to figure things out on your own. So stay away from sites like Chegg and stuff like that. Late work deadlines are going to be strictly enforced. There's deadlines posted on assignments, and when we talk about programming assignment 1, we'll talk about options for turning stuff in 1 day late. 1 day programs. We'll talk about in a minute. Other policies. All right, question. Anyway, delete existing projects. Sure, go to a project, go to settings, go to the bottom, go to advanced settings, go to the bottom of that, you'll find a delete option. It makes you work pretty hard to delete it. You have to like find all of that, and then you have to type in the name of the repository exactly. But it'll let you delete like that. I figured out how to delete projects from Linux using the API, but it's not a slam dunk. So, but that's what I do to remove myself from everybody's project after they've added me. Because right now I've got like 500 projects I'm a member of. And we'll talk about how to send emails on the Linux server. All right, so let's get into this stuff. Let's do Linux access. And again, I'm going to go through this assuming that you have not logged into the Linux server before. So if you're if your name is something like Barbara Johnson, your username is B Johnson. Okay, no period in between here, no number at the end. Okay, it's not your CTC ID. It's just first initial followed by last name as it appears in Canvas. Okay, unless you've asked me to use a different name. If your last name is hyphenated, it would be B Johnson dash whatever, right? But first initial and then the last name as it appears in Canvas. And the server is linux.engrcs.com. All right, so let's say I want to log in from Linux to the Linux server. So this will work on OS X, it'll work on Windows. I'm just going to use SSH. So SSH, my first name is Nick, my last name is Macias at linux.engrcs.com. All right, it's going to ask me for my password. What's my password? My password is my CTC link ID followed by an underscore. Okay, if you had an account in 224, I have not changed your password, so your password is still set. But if you got a new account, right, it's your 9-digit CTC link ID followed by an underscore. So I'll put in my password. If it's correct, you will get a login message which says, welcome to the Linux server, etc. And it forces you to change your password. Okay, first thing you have to do is retype your current password. Okay, this is not your new password. This has to be your current password. If you try to type your new password, it'll kick you out. All right, so in that case, go ahead and log back in. And then it'll ask for your current password. So put that in again. And then they'll ask for a new password. So type in your new password and then type in your new password again. If you get them wrong, it will say passwords do not match, password unchanged. If it says unchanged, that means you've still got the old password. So log back in again with your CTC link ID, followed by the underscore. And then try changing your password again. So first you have to type in your current Unix password, CTC link followed by underscore, and then type in your new password, and then type in your new password again. It'll log you out, but if it says password updated successfully, now you're set with your new password. So now you can try logging in one more time, put in your new password, and there you go. You've got Linux access. Let's see, should we delete files from 224? You can if you want. You can keep them around if you like. You can clean them up if you have multiple copies, but we should have enough disk space to get through the rest of this. We've still got 38 gig, so as long as everyone plays nice. Yeah, you don't have to delete old stuff. I get rid of all the stuff in usually August, so but you can keep it around until then. All right, so that's how you log into the Linux server. And that's one of these things, you know, if it's not working for you, send me an email right away, and I'll help you get logged in if you've forgotten your password or something like that. Because we want to get to the ODPs as soon as possible. So let me go ahead and log in as NCS. All right, so let's look at the ODP. So ODPs are these one-day programs. They're designed to be done with 24-hour turnaround. So ODPs will generally post at 10 in the morning, and they'll be due at 10 the following morning. And you write the code, and you can assess it yourself. You can run an assess command that will tell you if your code is correct or not. There's a link here to a video that basically talks you through the highlights of the system and what we're about to do. So here's ODP 201. It's a function named sum. Okay, so write a function named sum, takes two integers, returns an int, and there's a test bed which is under /temp/main.o. Alright, so what do? Write your sum.c, test it. Okay, see if you've written a function that adds two integers and returns an int. And once you're sure that that function's working correctly, go ahead and do what we call linking it to the test bed. So here's a GCC command. I'm going to link my program, sum.c, which has my function in it. I'm going to link that with the test bed, which is main.o. I'm going to generate an output file called ODP201. So that's building my testable image, and then I'm going to assess it with this assess command. Alright, so I already did this in the morning section, and I'm just going to be lazy and not type this code in again. So here's my sum function. Okay, it takes two integers x and y, returns their sum. Now before I assess that, I want to test it. So I wrote my own program, main.c, which tests my sum function. So what does it do? Well, I prototype sum, and I say, okay, let's call sum with the arguments 2 and 3, and let's print out what it returns. So I'm saying, you know, 2 plus 3 equals, and I'm going to replace that %d with, you know, the return from the sum function. And I'm going to try adding -2 and -3 and get back, you know, the result of the sum function. And then I'll just add some different numbers like this and get back the result of the sum function. Okay, so this is my own test program. So I can compile that up. And I get a warning because I didn't say main returns an int, but that's okay. And I'm going to run my program, and it looks like it's doing the right thing. Okay, so 2 plus 3 is 5, -2 and -3 is -5, and so on and so forth. So now I believe my sum function works. This is a really important step, though. Okay, when you're doing ODPs and they get, you know, more involved and they're using things that you haven't used before, or when you're writing programming assignments, or when you're writing up an answer on a test, or anything else where you're writing code, you want to be able to test that code, right? So the sum function doesn't do a whole lot. It takes two integers, returns their sum as an int. There's not a lot of wiggle room there, right? So, you know, testing this with 3 different sets of arguments is probably sufficient. But a more complex program, something that's going to take a string and, you know, run it through scanf and deal with exceptional conditions and do some recursion and so on, right? How do you test that? I mean, you can't test it with every possible set of inputs that you could ever imagine. So how do you come up with good test cases? And this is an important discipline to develop in yourself, right? How do you test code? You've written a function, here's what it should do. How do I know if it actually does the right thing? Now you can come up with a test program and see if it works in that case, but does that mean it works in every case? Probably not. You really need to think of lots of different ways to test it. And here, you know, there's not a lot of options here, but it would have been nice to try some zeros. If I was, you know, doing something that had to deal with overflow, I might try some numbers that potentially overflow, and things like that. So why is this important? Because if you can look at a program or a function you've written and start thinking of how you could test it, eventually you'll start doing that kind of analysis while you're writing the code. And eventually you'll start doing it before you start writing the code, while you're thinking of the algorithm. That part of your brain will be kicking in and saying like, hey, wait a minute, what if that input line is empty? What's going to happen then? And it will affect how you write your code, right? And this makes you a better programmer. So being able to think of how to test your code and writing test beds on your own is really good practice, right? And the more you can do this, the more you'll be thinking of these things as you develop your code, and the more successful you'll be at having code that works, you know, as you want the first time, barring syntax errors and stuff like that. Yeah, so someone says they let their family try and break stuff in long code. That's a great way to do it, right? Or get your cat to jump on your keyboard and see what your program does. All right, so here's my oh yeah, question. Go ahead.
So when I typed in what you did for your code, my thing returned this. I'm gonna copy and paste that.
Okay.
My code returned this. Yeah, and I guess and I can show you the rest of the code too.
So when you declare your function, yeah, so your function shouldn't be called main. So main is always the name of your main program.
Okay.
And so if you're writing your main program, right, I would just call it main paren or integer main or something like that. But your function that you want to assess is called sum. That's the one where you say integer sum. And then if you have arguments x and y, yeah, you have to specify the type. Integer x, comma, integer y.
Int x, int y. Okay.
Yeah.
Yeah, that's the problem I was having.
Right, so yeah, function declarations, you need a type of variable followed by the variable name for the parameters. And then you need a type for the function return itself. All right, good. So we've got our sum function. It works on our test case. We're ready to assess it. So what's the command for that? So gcc-o odp201/temp/main.o sum.c. I'm not using my main program anymore, right? I'm linking with the assignment's main program, which is main.o. And yeah, it's easier to call the output odp201 because if you call it test or something like that, that can confuse the assessment system. All right, so we'll link that up and then we'll go ahead and assess it. So odp201, and I'll put in my source code sum.c. So it takes 2 arguments. And you get the following screen. Okay, what you want to pay attention to here is this stuff between the lines of asterisks. You are about to assess your code for. Make sure this is what you want to assess. If you think that you're writing code for ODP 202 and this says you're about to assess ODP 201, you're in the wrong part of the timeline, right? So exit out of here. Don't assess your code unless your code is ODP 201, function to receive 2 integers and return their sum. Okay, now yeah, that's where I am. So I want to go ahead and assess, so just do an uppercase G, and 10 out of 10 on all 5 tests, I'm good to go. I'm done with my ODP, hit an X to exit, and that's it. All right, so that's the ODP setup. Let's see, how do you copy string 3 times? Highlight and then right click where I want to paste it. That works. Y to copy the line, P 3 times works also. Good. Yeah, cool. Excellent. The other thing is if you delete a line, you can also P to put it. But that gets people into trouble sometimes. You can also do like, 100P and it'll put it 100 times. Awesome. VI dialogue. Good stuff. All right, let's talk about homework 1. So back to Canvas. Tell me I didn't close my Canvas window. I did close my Canvas window. Alright. Back to Canvas. Alright, homework 1 is another hello world. If you've done Git before, if you were in 224, this is a rehash of, I think, homework 2 from last quarter. But you still need to do it. So, if you have not done Git before, right, and you're not familiar with Git, let me know. Take a look at the video, see if that makes sense, and if not, come by office hours or something, we can work through this. This isn't due until Wednesday, so we got an extra day of wiggle room in here. So, basically, make yourself a directory called homework001, initialize a Git repository, link it up with the remote server, and then make yourself a README file in there. Okay, and just tell me, who you are, what your Git experience is, something like that. And then copy your sum.c from ODP 201. So you have 2 files in your directory, README and sum.c. Add those to Git with git add. Commit them with git commit, and then push them to GitLab with git push origin master. I went through this in detail from the Linux server. In the previous section, I forgot to go and delete my repository, so I can't do it again. Because I already have a homework 1 over there. But watch the video if you're not sure on this. But just follow these step by step. Once you have the project over on GitLab, hop onto the GitLab website, go to the project, the members option, and add Nick Macias as a member, and set me up as a reporter. Okay, that lets me download your repository. Okay, to finish homework 1, you have to do one more thing, which is send me an email on the Linux server to tell me what your GitLab ID is. Okay, so my GitLab username is Nick Macias, so I would send the teacher an email with a subject, git:\space, and then the GitLab ID. Okay, so let's talk about how to do that. The Linux server, you can send emails on there. I don't recommend using that as a way to get a hold of me about something important, okay? It's not an officially supported email mechanism, but for this one case where I want to get this information from people and do something programmatic with it, it's a whole lot easier for me to do this on the Linux server than to download 50 messages from Outlook and try to parse them and all that kind of stuff. And yes, even if you did not change your Git ID, you still need to send me this because I have deleted the GitLab user ID list from last quarter. I didn't delete it, but I'm going to delete it and just make a clean slate from right now. So make sure you send me that email. Okay, how do you send email to me on the Linux server? So my username is Nick, so just mail Nick. Okay, mail's the name of the command. Nick is my username. Subject, so say git:, and whatever your Git ID is. Mine is Nick Macias. All right. And then to end your email message, you have 2 options. You can hit Control-D, which is the usual way to end input, and it'll tell you you didn't type a message, hope that's okay, which is fine. Or you can hit a period as the first character of a line followed by an enter. And that also says that's the end of my message. And it'll say the message body's empty, hope that's okay, which it is. All right. And that's it for homework 1. So make a directory, initialize Git in there, put in a pair of files, add those to the repo, do the git remote add origin to link it to a repository on GitLab called HW001, do the git push origin master to push it over there, hop onto the server, add me as a reporter, and then on the Linux server, go ahead and send me an email with the subject git:\space followed by your Git ID. And we'll see how many people can do it in exactly this format. Because if it's not in exactly that format, then I have to pull it out and parse it separately and so on. So let's see how close we get to 100%. All right, so that's homework 1. And as usual, any questions on any of this stuff, right? Best option, just pop up your microphone and say, hey, I'm not sure about something. Can I ask you? Or post it in chat, and I don't know if I'll see it. And somebody has their hand up. I don't know if that's still supposed to be up or if I have to lower it or what. I haven't used the hand raise feature. Yeah. Well, let's see how my email looks on the server.
Hey Nick.
Yeah.
So I guess I'm having a problem with the GCC.
Okay.
When I try to run it with sum.c at the end, it says no such file or directory. Like the command that you
GCC
put on
space
campus.
sum.c.
Yeah, I'll just copy paste exactly what I put in.
Okay. So first question would be, do you have a sum.c in your current directory? Yeah, exactly.
Oh,
Because I think maybe you named it main.c.
No, I don't.
Okay, so that last file name is whatever the name of your file is that you want to compile.
Okay, can I use the ODP file with all the tests, or do I have to like create a sum.c and copy paste it in there? With some function.
You can call it whatever you want.
Okay.
But I usually recommend what I want it called. And that will be in harmony with what we talk about in class, so it's probably less confusing to stick to that. But the function name itself is critical. That has to be SUM in this case.
Okay.
And the function name will always be specified, and that's what the test bed will look for. All right, cool. So there's a quiz on Canvas that is due tomorrow. This is just a hello world for quizzes. So go ahead and take that. It's 1 question. I think you can probably answer that with a few hours of online research or maybe less. So it asks you what class you're taking. So hopefully everybody knows it's CSE222. So do that quiz, and that gets you your 1 point. All right, let's talk about SLPs. So service learning projects. So this is a new component because we did not do SLPs in fall quarter. So service learning project. I mentioned this briefly in 224. Basically, it's a multi-term project of your own choosing that counts as part of 222 and 223. It should be a project that you're interested in working on, and it can be almost anything. It can involve hardware, software. It can be game design. It can be home automation. It could be web-based. But the goals of the SLP are basically to give you a long-term project, something that's going to take 20, 25, 30 weeks to do, that you can really sink your teeth into, and something that you're excited about, something you want to spend time working on. It does not have to be C-based. It could be a chance to learn a new language. You want to figure out what assembly language looks like on an Arduino. You could build a project around that. You want to learn Spitball and Snowball. You could build a project around that. So sky's the limit, right? And there are so many goodies out there right now. There's single board Jetson boards you can get from SparkFun, from NVIDIA, that have machine learning infrastructure built in at hardware level. It can be a project you've already started. It could be a project that you've been working on, and now you can continue working on it and actually get credit for it in some of your classes. So I asked you in 224 to spend some time, over break, thinking about what you'd want to do for a project. And if you had a chance to do that, great. If not, start doing that as soon as possible. And your first deliverable for this is the proposal. So let me show you the download for this. and this is just kind of an overview, right? So this is what we just said, choosing a topic and so on. Here's what I want you to submit, okay? And this is due a week from Wednesday. The following information. Now, please don't just take this and add a few lines in between. Make this a full proposal, okay? I'm not picky about the format or the style, but I want, complete sentences. I want something that you could hand to somebody and they would understand what the heck you're talking about, okay? So here's what I want you to turn in. Name, class, date, name of the project if you have it, people you want to work with. Okay, you can work in groups of up to 3 people. Okay, but make sure that it makes sense if you're going to partner with someone. Make sure you understand what you're going to do. You have similar ideas about timelines and deliverables and work approach and things like that. Okay, most people work on these things by themselves. Project description. Tell me about your project, right? Be as wordy, as detailed as you possibly can. Don't just say, I want to write a video game, right? What kind of video game? What's it going to do? What's it going to play like? How is it derived, from other things? How's it going to be better than other things? What do you hope this is going to look like, Spell it all out here. Yes, you can do it in a group, up to 3 people. Let's see. Tell me the most challenging elements, what you expect to learn from this. This should be a project you don't already know how to do. It should be a project that pushes you, right? That forces you to learn more and be able to do more than you can do right now. So what do you expect the challenges are going to be? What's the service component, right? Put on your marketing hat. How is this going to be useful to other people? And, you can do just about anything for this. A video game is useful because it helps people relax. It helps people unwind and so on and so forth. If you've already done some work on this, tell me what you've done in the past on it and what the current status is. And then milestones. This is a key part of the project. Okay? Very, very specific, measurable milestones for partway through this quarter, for the end of this quarter, and for next quarter. And you can have more than this. You could have, 3 milestones for this quarter if you want. So what's a milestone? It's a clearly measurable, well-defined metric of where you should be at a certain point. So by February 1st, 2021, my game should be rendering a playing field and a non-controllable character. By February 8th, the character should be movable with the cursor arrow keys. By February 15th, you should be able to move around the playing field and see areas off the screen. By March 1st, I should have basic interactions with one enemy that I can fire at and try to evade bullets. By March 15th, which is the end of the term, I should have a playable version that goes through one level, etc., right? So very, very specific. So that when you get to February 1st, you can look at your project, look at your milestone, and say, I met my milestone, or I'm behind schedule, or I'm ahead of schedule. Okay? So the milestones are critical. Major challenges you anticipate, and then just tell me about the project. Why did you choose it? Why are you interested in this? What do you hope to learn from it? And so on and so forth. Okay, so that's the SLP, and I want you to make me a PDF document that contains all of this information and anything else that you think might be relevant, and then upload that to Canvas by the deadline. And this should be a project that takes you at least 2 quarters to do, and you'd like to get to, a presentable point, by the end of spring quarter. But if it's something that's going to go further than that, that's fine. It should not be something you can do in a few weeks, or that you can completely finish in just 1 quarter. So think about scope. If you want to iterate with me on this, you can send me emails and ask me for ideas, or tell me your idea and ask me what I think and so on, and we can go back and forth on that. All right, so that's a longer term deadline that's due on the 13th, which I believe is a week from Wednesday. All right, that's all I got today. We will start talking about data structures tomorrow, so I will see you then. Have a good afternoon, and if you're in 215, I'll see you in 215. All right, thanks.